Okay, let's dive in. Ever thought about how cool it'd be if a computer could, like, really understand a document?
Yeah.
I'm talking not just the words, but the charts, the layout, the whole meaning behind it.
Like, get it the way we do.
Exactly. Well, that's what this deep dive is all about. Document layout analysis.
Or DLA for short.
DLA, right. And we're going to zero in on a pretty awesome new approach called DLAFormer.
It's really interesting stuff.
We've got this research paper from some really sharp folks. They're from the University of Science and Technology of China.
And Microsoft Research Asia, too.
Right, and Microsoft Research Asia.
They're really pushing the boundaries here.
Yeah, what makes DLAFormer so special? What's the big deal?
Well, think about how we usually analyze documents. We might have one system for finding tables, another one for spotting headings, and so on.
Right, kind of like a team of specialists, each with their own task.
Exactly. But DLAFormer flips the script. It sees the whole document as one big interconnected puzzle.
So instead of a bunch of separate models, we've got one super efficient document whiz.
You got it. And it actually outperforms those specialized systems in a lot of cases.
Wait, so one model does it all?
One model, powered by what's called a transformer network.
Hold on, transformers. Aren't those the things behind, like, ChatGPT and all those chatbots everyone's talking about?
That's right. But transformers aren't just for language anymore.
Really?
They're amazing at understanding relationships between things, which turns out to be perfect for analyzing documents.
I don't quite see the connection. How does understanding relationships help with documents?
Well, think about a document. A caption relates to an image.
Yeah.
Headings structure a section. Footnotes give you extra info. It's all about connections.
Okay, I'm starting to get it. But how does this DLAFormer actually figure out those relationships? The paper mentioned something about queries.
The queries.
Honestly, that part kind of went over my head.
No worries. It's actually pretty intuitive. Think of queries as questions that DLAFormer asks the document. Each query represents a specific element, like a table or a figure or a heading.
So it's like giving the model a set of questions to ask the document to figure out how everything fits together.
Exactly. It's like asking, hey, document, show me all the tables and tell me what they're about. Or where are the headings? What's the main topic of this section?
Clever. But the paper also mentioned something called a type-wise query initialization module.
Oh, yeah, that's a mouthful, isn't it?
Now, that sounds even more complex. Can you break that down for me?
Sure. It's basically a way to help DLAFormer understand those different elements even better. It learns specific features for each query type, like what makes a table look like a table? What are the visual cues that distinguish a figure from a paragraph?
So it's like giving our detective a specialized magnifying glass for each type of clue. Makes sense.
Exactly. So it's not just asking, show me the tables.
Right.
It's understanding what makes a table, so it becomes a much better detective.
That's clever. So it knows there's a table, but how does it go from knowing that to actually pinpointing it on the page? Like, this is where the table starts and this is where it ends.
Good question. DLAFormer does this in 2 steps. It starts with a rough idea of where something might be, and then refines its prediction to get the exact location.
So it's a bit like, trying to find a friend in a crowded park. First, you scan for someone who looks like them, and then you zero in on specific details to make sure it's actually them.
That's a great analogy.
Is that how it works?
Yeah, that's exactly how DLAFormer makes sure it's not just guessing, but actually zeroing in on the right spot.
Yeah.
And to see how well all of this works, the researchers put it to the test, using some benchmark data sets.
Benchmarks. Okay, let's talk about that. First up, we have CompHRDoc. What's the challenge there?
CompHRDoc focuses on the structure of a document. Can the system identify different elements, like tables, figures, and can it understand the reading order, especially when things get complicated?
So like those documents that have lots of nested elements.
Right, like a table within a section, within a chapter, and so on.
And DLAFormer, how did it do?
It did really well. Yeah, outperformed a lot of other methods, especially when it came to tricky things like formulas and page headers. Those are often really context-dependent.
Right, so not just the easy stuff. Okay, but what about DLANet? How is that one different?
DLANet is huge. Yeah. Tens of thousands of pages, all sorts of sources, financial reports, patents, manuals, the works, really trying to mimic the real world.
Wow, that's a lot of data.
And the level of detail is insane. It's not just, hey, that's a paragraph.
Right.
It's like, is that a caption? A footnote? A list item?
It's much more granular.
Yeah, really pushing the limits.
And how did DLAFormer hold up against that? Was it able to handle all that data, all those nuances?
It did remarkably well. Even with all that diversity and complexity, it exceeded the performance of many other cutting-edge approaches. So it can definitely handle the kind of documents we see every day.
Okay, so this thing can handle complex layouts, pinpoint those tricky elements, but how does this all affect the average person? How could this change how you and I interact with documents?
Well, imagine being able to ask your computer to pull out the key takeaways from a massive report, right? Or just understand the main points of a research paper instantly.
No more scrolling through pages and pages.
Exactly. No more skimming, no more highlighting. DLAFormer could be the engine behind that kind of intelligent information access.
That's what I'm talking about. But the research team isn't stopping there, are they?
Oh no, they're dreaming even bigger for DLAFormer.
Spill the beans. What's next on their agenda?
Well, imagine DLAFormer not just spotting a table, but understanding the data inside it. Or, like, really getting the hierarchy of a document structure.
So it's not just recognizing elements.
Right. It's about extracting real meaning and understanding.
So there are any potential downsides to all of this? Should we be worried about, computers and understanding our documents so well?
It's a great question, and definitely one that researchers are thinking about. We want to make sure that as this technology advances, it's used responsibly and ethically.
Okay, good to know. So DLA is still in its early days, but it has the potential to really change how we access and process information. But DLAFormer isn't the only game in town, is it? What other cool things are happening in the world of document layout analysis?
There's a lot of great research going on. One trend that I find really exciting is the move towards multimodal analysis.
Multimodal analysis? That sounds interesting. Tell me more about that. What is it and why is it so important?
Well, documents aren't just words on a page anymore, are they? We've got images, videos, audio, interactive elements. It's all mixed in.
Yeah, sometimes my own notes look like a multimedia collage.
Exactly. So multimodal analysis is about developing systems that can understand all those different types of information seamlessly to create a really complete understanding of a document.
So the future of DLA is not just text and images.
Nope. It's about how they all work together. It's a challenging area, but researchers are making some real progress. Imagine systems that can analyze a video presentation,
Wow.
understanding the spoken words, the slides, even the speaker's gestures.
That's some next level document understanding.
Yes, it is.
Okay, but let's bring it back to the star of the show, DLAFormer. What were some of those key innovations that made it so groundbreaking? What really sets it apart from the rest?
One thing that really impressed me was how it handles relationships. It's not just about identifying elements, but understanding how they relate to each other. And that's a really big deal.
Can you unpack that a bit? Why is that focus on relationships so important?
Think about reading a scientific paper, for example. You don't just read the words in isolation. You pay attention to the headings, the figures, the citations, how they all connect to create the overall story.
It's like seeing the forest and the trees at the same time.
Exactly. And that's what DLAFormer does so well. It sees the individual pieces, but also sees the big picture, the connections that give the document its structure, its meaning.
That's pretty cool. It's almost like it's reading with a critical eye, looking for those underlying patterns and connections that a less sophisticated system might miss. But how does it actually do that? What's the magic behind it?
Remember those queries we talked about? They play a big role here. Each query is like a targeted question designed to uncover a specific type of relationship.
So it's not just asking, is this a table?
Right.
It's asking, how does this table relate to the surrounding text?
Exactly. Is it supporting an argument? Is it clarifying a point? By asking those targeted questions, DLAFormer really digs into the document and understands those subtle connections. It's a step closer to how we as humans read and comprehend.
I'm starting to get why DLAFormer is such a big deal. It's not just about recognizing elements, it's about understanding how those elements work together to convey meaning. And that deeper level of understanding, well, that's what unlocks so many of the potential applications we've been discussing, right?
Exactly. Whether it's summarizing a complex report or pulling insights from a ton of data or even personalizing how we learn.
It all comes back to understanding those relationships.
Absolutely.
All right, so relationships are key. But I'm curious, what else about DLAFormer stood out to you? What other innovations made it so special?
The way it handles the actual detection of elements is really impressive. It uses this course-defined approach that's both efficient and incredibly accurate.
Remind me, how does that work again?
Imagine using a map to find a specific location. You might start with a regional map to get a general idea of where you are. Then you zoom in to a city map to find the right street. And then finally, you use a detailed building plan to pinpoint the exact room.
So it's like a step-by-step process, getting more and more precise.
Yeah, exactly. DLAFormer does something similar. It starts with a broad estimate and then refines its prediction layer by layer.
So it can handle even the most complex layouts.
Yeah, even when things are really cluttered, it can find those exact boundaries.
That's impressive. But even with all these advances, I have to ask, what's next for DLA? Where do we go from here? What are the frontiers?
Well, the DLAFormer team is already hinting at some really exciting future directions.
Okay, I'm all ears. What's on the horizon?
Well, one area they're looking at is handling even more complex document types. Right now, these systems are really good at things like articles, reports, textbooks, nicely structured documents.
Right, those ideal cases.
But what about things like handwritten notes, diagrams, documents with multiple languages?
Yeah, those can be a mess. Even I have trouble deciphering my own handwriting sometimes.
Exactly.
Yeah.
But researchers are coming up with new techniques, often using deep learning, to tackle those challenges. Imagine extracting meaning from even the messiest handwritten notes.
Wow.
Or understanding diagrams just as easily as we understand text.
Now that would be a game changer, especially for those of us who are more visual thinkers.
It would. But it's not just about expanding the types of documents.
What else?
Another really exciting area is integrating DLA with other AI technologies, like natural language processing.
Right, we talked about that a bit earlier.
Imagine a system that can understand the layout of the document, but also really grasp the meaning of the text itself.
Yeah, that would be amazing. It would be like going from recognizing a word to understanding its definition, its context.
Exactly. It's not just about structure, it's about content and meaning. And that's where things get really interesting.
Okay, that's a lot to think about. But I'm curious, how did the researchers actually develop and train this incredible DLAFormer system? What kind of data did they use? What were the key steps in the process?
Well, training a sophisticated AI system like this is a pretty complex process. There are a lot of moving parts. Data preparation, model design, training, evaluation, this whole journey.
Let's break it down. First up, data preparation. What kind of data did they feed into this DLAFormer machine?
You know that saying, you are what you eat? Well, for AI systems, it's more like you are what you learn from. DLAFormer, like any deep learning model, needs tons of data to learn from.
So not just a handful of documents. We're talking about training on a massive scale.
Massive scale, exactly. And it can't just be any random documents. This data needs to be carefully curated and annotated to give the model the information it needs to learn. For DLAFormer, they use a mix of publicly available data sets, like the ones we've talked about, and also some proprietary data they collected and labeled themselves.
Ah, so it's like creating a gourmet meal for a very picky eater. You need the right ingredients, prepared in just the right way.
That's a great way to put it. The data needs to be representative of the real world, diverse, so the model can handle different types of documents. And it needs to have all those detailed annotations so the model knows what's what.
Okay, so you've got your data prepped and ready to go. What's next?
Model design. This is where the researchers act like architects, figure out the algorithms and techniques that DLAFormer is going to use. And for this one, they went with a transformer-based architecture, which, as we discussed, is really good at those relationships.
Ah, so that's where the transformers come in.
Exactly. They're like the masterminds of the AI world these days.
They're not just for language anymore.
Nope. Really good at those complex relationships. And that's key for analyzing documents accurately.
Okay, so we have our data, our model's designed. What's next? Time to put this DLAFormer through boot camp.
Exactly. Time for training. It's kind of like teaching a puppy new tricks. You show it what you want it to do, you give it feedback, and over time it gets better and better.
Lots of repetition.
That's the core of it. With DLAFormer, you give it documents, it makes predictions about the structure, and then you tell it how it did.
So it's like giving it a pop quiz on document layout and then grading its answers.
Exactly. And with enough quizzes and feedback, it becomes a document understanding whiz.
That makes sense. But it's not a quick process, is it?
No. Training a model like this can take days, weeks even, depending on the data and the complexity. It's computationally intensive.
A lot of number crunching.
It is. But the results are worth it. But of course, training isn't the final step. You have to make sure it can handle new documents, ones it's never seen before.
Right, so it can generalize. It's not just about memorizing the training data.
Exactly. It has to apply what it's learned to new situations. And that's where those benchmark data sets come in. They're like the final exam.
Okay, so data preparation, model design, training, and evaluation. Each step is crucial for building a really robust DLA system. But before we get lost in the technical details, I want to point out that this DLAFormer paper is just one piece of a much bigger puzzle. There are lots of other teams out there working on DLA, each with their own approaches.
That's a really important point. DLAFormer is a big step forward.
It is.
But it's part of a much broader research landscape. There are lots of other exciting things going on that we haven't even touched on.
Like what? Give me a sneak peek.
Well, one area that's particularly fascinating is the push towards personalized DLA systems. Remember we talked about that earlier?
Yeah.
Imagine a system that can learn your unique preferences and habits when it comes to documents.
So instead of one size fits all.
Right. You have a system tailored to you, your way of thinking, your way of working.
That's pretty cool.
It is.
Yeah.
And it could lead to some really intuitive ways to interact with documents.
Imagine a DLA assistant that anticipates what you need before you even ask. Helps you find exactly what you're looking for, even if you don't quite know how to describe it.
Now, that's a future worth getting excited about.
I agree. And there's another area that's really pushing the boundaries of DLA, the intersection of DLA and knowledge representation. Okay, I'll bite. What is knowledge representation, and why is it relevant to DLA?
So traditional DLA systems, they're mostly focused on understanding the structure of documents, the layout, you know.
All right, like we've been talking about.
But what if we could go further and actually extract the knowledge contained in those documents?
So it's not just recognizing a paragraph about a topic.
No.
It's about understanding the concepts and relationships within that paragraph, representing that knowledge in a way that a computer can use.
Exactly. That's where knowledge representation comes in. It's about developing these formal languages and methods for representing knowledge, so computers can process it and reason about it.
That sounds pretty complex, but I can see how it could be really powerful when paired with DLA.
It is. Imagine asking your computer, what are the main causes of climate change?
Okay.
And it not only finds relevant documents, but summarizes the information for you in a way that makes sense.
Wow, that would be amazing.
It would, like having this vast library of knowledge organized and accessible in a way that humans can understand.
And that's the goal here.
That's the ultimate goal, to make information more accessible, more understandable, more useful.
That's a powerful vision. But as with any powerful technology, there are also risks. Ethical considerations we need to be thinking about, right?
You're absolutely right. As these DLA systems get more sophisticated and become more common, we have to consider things like privacy, bias, fairness.
Make sure they're used for good.
Exactly. We want to benefit society as a whole. It's a conversation we need to have. But for now, let's take a quick break, and when we come back, we'll dig even deeper into DLAFormer and its potential impact on your life. Welcome back. We were just talking about all the potential of DLA, really exciting stuff.
It is exciting, but, no technology is perfect. Even this amazing DLAFormer. Are there any limitations to it? What can it do?
Well, you're right. No technology is perfect. And even DLAFormer has its challenges. One of the big ones is that it's mainly trained on those really well-structured documents.
You mean like textbook perfect?
Yeah.
Everything's neatly formatted, headings, paragraphs, images with captions.
Exactly. That's where it really shines. But when you start looking at the messier side of documents.
Oh, like my handwritten notes?
Things like that, yeah. Handwritten notes, emails with weird formatting, overlapping elements.
You know those emails where someone's hit reply all 20 times and it's just a jumbled mess?
Exactly. That kind of stuff can really trip up DLAFormer. It might not be able to identify elements accurately or figure out how they relate.
Okay, yeah, I can see that being a challenge. It's like teaching someone to read sheet music and then throwing a free jazz score at them.
That's a great analogy. And that's why researchers are focusing on developing DLA systems that can handle more diverse, unstructured content.
Makes sense. We need a DLA that can handle the real world, not just a perfectly organized world.
Exactly. And speaking of the real world, one question that comes up a lot is about language.
Oh, right. Does it actually understand the words? Or is it just looking at the visuals?
That's a great question, and it gets to the heart of what DLA is all about. Right now, DLAFormer is mainly a visual tool. It's not processing the meaning of the words, but recognizing the visual patterns and relationships.
So it can tell me this is a heading, but it doesn't necessarily understand what the heading says.
That's right. It's like being able to recognize a stop sign without understanding traffic laws.
Okay, I get it. But I can imagine a future where DLA and natural language processing, they work together, right?
Absolutely. That's a huge area of exploration, integrating DLA with NLP. Imagine a system that can identify a table extract the data, and actually understand what it means.
So it's not just recognizing words, it's comprehending them.
Exactly. And that brings us to another fascinating aspect of DLA, multimodality.
Right. We talked about that a bit earlier.
We've been focused on the visual side, but documents often have audio, video, interactive elements.
Like those presentations with embedded videos or websites with all the bells and whistles.
You got it. The future of DLA is likely going to involve systems that can handle all of that seamlessly.
Create a much richer understanding.
Exactly.
Yeah.
But let's zoom back in on DLAFormer for a moment. What aspects of its approach really stood out to you?
You know, I was really impressed with how it uses those type-wise queries. It's not just asking, is there a table here, but having a specific tool for each type of element.
It's like having a specialized detective for each type of clue.
Right. Fingerprint expert, handwriting analyst, they each bring your own expertise.
And that seems to be a big part of why DLAFormer is so accurate. It's not just seeing patterns, it's understanding the specific features of each element.
Okay, so those type-wise queries, they give it a deeper level of understanding. It's not just seeing shapes on a page, it's recognizing what makes a table, what makes a heading.
Right, it's seeing those subtle cues that distinguish different things.
Yeah.
So we've talked about its strengths, but how was it actually evaluated? You mentioned those benchmark data sets, CompHRDoc and DLANet. What can you tell me about those?
Yeah, how do we know this thing actually works?
Well, those benchmark data sets, they're like obstacle courses for AI systems. They give you a standardized way to test how well a system performs specific tasks.
So for DLA, these data sets are basically collections of documents, all carefully labeled.
Exactly. Information about the layout, the structure, everything. And you use them to test how well a system can analyze and understand different types of documents.
So you just throw a document at it and see what it comes up with.
That's the basic idea. You see how accurately it can identify elements, classify them, figure out how they relate.
Okay, so let's talk about CompHRDoc. What kind of documents does it use and what does it test for?
CompHRDoc is all about those complex, hierarchical documents. Scientific papers, legal documents, anything with lots of nested elements and tricky layouts.
So not just your average blog post.
Definitely not. It's designed to really challenge a system's ability to understand structure. And the tasks include things like identifying all the elements, tables, figures, headings, and figuring out the reading order.
Which can be tough with those complex layouts.
Exactly. And DLAFormer did really well on this one. Achieved state-of-the-art results, outperforming a lot of other methods.
So it passed the test.
Passed with flying colors. Especially when it came to those tricky elements like formulas and page headers.
Those are the ones that really require understanding the context.
Right. It's not just about recognizing visual patterns. It's about understanding the meaning and the structure.
Okay, so it aced CompHRDoc. But what about DLAFormer? How is that one different?
DLANet is like CompHRDoc on steroids. It's massive, tens of thousands of pages from all sorts of sources. Financial reports, patents, manuals, you name it.
Wow, that's a lot of documents.
It's designed to be as diverse and representative of the real world as possible. And the level of detail is incredible. It's not just about identifying a paragraph. It's about figuring out if it's a caption, a footnote, a list item.
So it's testing for nuance and granularity.
Exactly. It's really pushing the limits of what these systems can do.
And DLAFormer, was it able to handle it? All that data, all those details?
It did exceptionally well. Even with all that diversity and complexity, it outperformed a lot of other cutting-edge approaches. So it's not just a one-trick pony. It can handle a wide range of document challenges.
That's impressive. It seems like DLAFormer really is a game changer. But I'm curious, what were the actual steps involved in training this system? How did the researchers go from algorithms to a machine that can understand documents?
Training a deep learning model like this is a bit like baking a cake. You need the right ingredients, the right recipe, and the right oven to get a delicious result.
Okay, I'm intrigued. Break that down for me. What are the key ingredients here?
First, you need your data. We talked about the importance of having a large, diverse, well-annotated data set. That's your foundation.
So that's the flour, the eggs, the sugar.
Exactly. Then you need your model architecture. That's your recipe, the blueprint for how the system is going to learn. And for DLAFormer, they went with that transformer-based architecture.
Right, which is really good at understanding relationships.
Exactly. And then you need your training process. That's your oven, the environment where the model is going to bake and learn.
And during that training process, it's basically being fed all that data, making predictions, getting feedback, and learning how to do it better and better.
That's the idea. It's a gradual process, like refining a cake recipe until you get it just right.
So it's not just a one-time thing. It's a process of trial and error, constant improvement.
Absolutely.
Yeah.
And it requires a lot of patience and a lot of computing power. But the result is a model that can understand documents, even ones it's never seen before.
Okay, so the cake is baked, but we're not done yet, right? What's the final step?
The final step, and arguably the most important, is evaluation. You wouldn't serve a cake without tasting it first, right? Same thing with the DLA system. You have to test it rigorously.
So that's the taste test, the moment of truth.
Exactly. And that's where those benchmark data sets come in again. They give you a way to assess how well your model does compared to others. It's like having a panel of expert judges critique your cake.
I'm picturing those cooking shows where they have the blind taste tests.
Exactly. And in this case, the judges are those carefully designed metrics that measure how accurately the model can identify elements, classify them, predict relationships.
So it's not just about, does it look good? It's about, does it actually work?
Exactly. It's about making sure that your DLA system can perform well in the real world. So we've talked a lot about DLAFormer, but it's important to remember that this whole field is vast. There are lots of other teams exploring different approaches, different ideas.
What are some of the other trends that you're excited about? Where do you see this field heading?
One trend that I'm particularly excited about is the focus on multimodal analysis. Remember we talked about how documents aren't just text and images anymore?
Right, they're becoming much richer, more multimedia.
Exactly. So multimodal analysis is about developing systems that can handle all that complexity. Systems that can understand and integrate different types of information seamlessly.
It's about seeing the whole picture, not just isolated pieces.
That's a great way to put it, and that's going to be essential for making DLA truly effective in our world.
Makes sense. What else is on your radar? What other trends are you seeing emerge in the DLA landscape?
Another trend that I find fascinating is the move towards more robust and adaptable systems. Traditional DLA systems, they often struggle when things aren't perfect.
Yeah.
Like blurry images, handwritten text, inconsistent layouts.
Like they're expecting every document to be perfectly formatted and pristine.
Exactly. And the real world is messy. So researchers are working on making these systems more resilient, more adaptable.
It's like teaching them to be street smart.
Exactly. They need to be able to handle the unexpected. And they're using techniques like deep learning to do that. Automatically cleaning up noisy images, correcting errors, handling variations in layout.
So we've got robust DLA, multimodal DLA. Anything else that's particularly intriguing to you?
Well, one area that has a lot of potential is personalized DLA. We touched on it earlier. But imagine a system that can actually learn your individual preferences and habits.
So instead of one size fits all, you have a DLA system that knows you, knows how you think, how you organize information.
Exactly. And that can lead to some really amazing possibilities. A system that can anticipate your needs, personalize your search results, even help you organize your thoughts and ideas.
That sounds incredible. But we're not quite there yet, right? What are some of the challenges in actually making that happen?
One of the big ones is privacy. How do you create a system that learns from your data without compromising your privacy? It's a tricky balance.
Right. I wouldn't want my DLA system reading my personal diary or analyzing my private emails.
Exactly. So researchers are developing techniques to make sure that these systems can learn from user data without actually storing or sharing it in a way that could be compromised.
Okay, so privacy is one hurdle. What else are researchers working on when it comes to personalized DLA?
Another challenge is just the complexity of human behavior. People are diverse, unpredictable, and they're always changing. So creating a system that can truly understand and adapt to those individual nuances, it's a tough task.
It's like trying to predict the weather, but for human behavior.
Exactly. But researchers are making progress, using techniques like reinforcement learning and user modeling to create systems that are more adaptable and responsive.
So personalized DLA is definitely a frontier with a lot of potential and some challenges to overcome. But let's shift gears a bit and talk about knowledge representation. Earlier, you mentioned this idea of fusing DLA with knowledge representation. Can you elaborate on that a bit more? What does it mean, and why is it so exciting?
Knowledge representation is all about capturing and representing knowledge in a way that computers can actually understand and reason about. It's about going beyond simply storing data and moving towards actually understanding what that data means.
So it's like teaching a computer not just to read a book, but to understand the ideas within it.
Exactly. And when you combine that with DLA, you start to open up some really amazing possibilities.
Uh-huh.
Imagine a system that can analyze a scientific paper, for example, and then represent the key findings and arguments in a structured format.
So it's not just extracting information, it's organizing and understanding it.
Right. And then you could use that structured representation to answer questions, make predictions, even generate new insights. It's really powerful stuff.
Okay, I'm starting to see how knowledge representation could take DLA to a whole new level. It's not just about recognizing elements anymore, it's about understanding what those elements mean, how they relate to each other, what knowledge they convey.
Exactly. It's about moving from data to knowledge and then using that knowledge to do amazing things.
Mm.
But as with any powerful technology, we have to be mindful of the ethical implications.
Right, we talked about that earlier. Privacy, fairness, accountability.
It's not just about making these systems smarter, it's about making them better, making sure they're used for good, that they benefit everyone. But for now, let's take a quick break, and when we come back, we'll wrap up our deep dive into the fascinating world of DLAFormer.
And we're back, wrapping up our deep dive into DLA. It's been a wild ride.
Yeah, we've covered a lot, from how it works to how it could change everything.
Exactly. So for our listener, someone who's been with us this whole time, what are the big takeaways? What should they be most excited about when it comes to DLA?
I think the biggest thing is that DLA has the potential to revolutionize how we deal with information.
Yep.
Think about it. No more struggling to find what you need. No more feeling overwhelmed by a mountain of data.
It's like a superpower for information, right?
Exactly. DLA could make information so much more accessible and understandable. Make it actually useful for everyone.
I love that. So, big picture, where do you see DLA heading in the next few years? What are the big trends that are going to shape this field?
One trend that I'm really excited about is the move towards personalized DLA.
We've talked about that a bit.
We have. But just imagine a DLA system that really understands your individual needs, your preferences.
Not just processing documents, but understanding the person behind them.
Exactly. It's about creating systems that anticipate what you need, tailor your search results to your interests, maybe even help you organize your thoughts better.
It's like a personal AI for information. Pretty cool. But what are the hurdles? What's standing in the way of making that happen?
Well, privacy is a big one. How do you create a system that learns from your data without, being creepy?
Right. I don't want my DLA going through my private stuff.
No, exactly. So researchers are working on privacy-preserving techniques, ways to learn from data without actually storing it or sharing it in a way that could be risky.
That makes sense. A balance between personalization and keeping things private.
Right. And the other big challenge is just how complex people are. We're all different. We're unpredictable.
And we're constantly changing.
Exactly. So trying to create a system that truly gets that adapts to each individual.
It's a tough task.
It is. But, researchers are making progress. They're using things like reinforcement learning, user modeling, to create systems that are more adaptable, more responsive.
So personalized DLA, definitely a frontier. A lot of potential, but some big challenges too. But let's talk about another big trend, that fusion of DLA and knowledge representation. I'm still wrapping my head around that one. What does it really mean? And why is it so important?
So knowledge representation is about capturing knowledge, representing it in a way that computers can work with.
So it's not just about data.
No, it's about meaning. It's teaching a computer to not just read, but to actually understand.
Ah, that makes sense.
Yeah.
So combine that with DLA, and what do you get?
You get systems that can analyze documents, extract the knowledge, and then use that knowledge to do things. Answer questions, make predictions, generate insights.
Wow. So it's not just about recognizing a table. It's about understanding the data in that table and what it means.
Exactly. It's about moving from data to knowledge, and then using that knowledge to make things better, to solve problems.
Pretty powerful stuff. But as we've talked about, it's important to be thoughtful about the ethics, right? As these systems become more powerful and more integrated into our lives.
Absolutely. Privacy, fairness, accountability. These are all things we need to consider. We want to make sure this technology is used for good, that it benefits everyone.
That's a great point. Technology is a tool, and it's up to us to use it wisely. But I'm excited. I think the future of DLA is really bright.
I agree. We're just getting started, and I can't wait to see what we can accomplish with this technology.
And on that note, we'll wrap up our deep dive into DLA. Thanks for joining us, and until next time, keep exploring.